Alright, my name is Tyler Janet and Professor Rembold's Physics 221. This is video homework assignment 1. So the objective for this assignment says, I can utilize velocities at different time points to determine the net force corresponding to an interaction in 3 dimensions. So the problem that I came up with to satisfy this objective says, say a car that is 1,000 kilograms has an initial velocity of 50, 10, 20 meters per second. After 5 seconds, the car has stopped. What is the net force needed to stop the car during the 5-second interval? So working towards the solution, the first step is to recognize that the momentum vector equals the mass times the velocity vector of the object in question, and that the change in the momentum vector equals the net force vector times the change in time. The second step in this solution is to rearrange this equation for the change in the momentum vector to solve for the net force vector. So we do that by dividing the change in time over to here, and we get that the net force vector equals the change in the momentum vector divided by the change in time. So the next step is to start plugging in values to find the momentum vector, which we know from before in the equations that we so kindly memorized, that the momentum vector is the mass times the velocity vector. So our mass of the car is given above in the problem, 1,000 kilograms, as is our velocity vector, which is 50, 10, 20 meters per second. So we multiply those two values together, crunch it into our calculator, and we get that the momentum vector equals 50,000, 10,000, 20,000 kilogram meters per second would be our units. Continuing on to step 4 here. In step 4, we got to find the change in the, let me fix this real quick, the change in the momentum vector here, so that we can plug in our final values to ultimately get this equation to find the net force vector. So the change in the momentum vector is equal to the final momentum vector minus the initial momentum vector. So obviously the final momentum vector is 0, 0, 0, since the car has come to a stop during the 5-second interval. So since it's at a stop, there's no momentum. So it's 0, 0, 0, and our initial is what we just found, 50,000, 10,000, 20,000 kilogram meters per second. We subtract those from each other, final minus initial, and we get negative 50,000, negative 10,000, negative 20,000 kilogram meters per second. Then we go to step 5, which is plug in the values to find the net force vector. So we just take this change in momentum vector and we divide it by the change in time, which is given up here, 5-second interval. So we do that, we plug these into our calculator, and we get negative 10,000, negative 2,000, negative 4,000, and the units for force is newtons. So there we go. There's our problem for video homework assignment 1, satisfying the objective that I can utilize velocities at different time points to determine the net force corresponding to an interaction in 3 dimensions. Thanks.